Okay, so let's go ahead and do some applications. The first round, I actually give us the function, and we just basically use that function to answer some questions. So we have an object that's in simple harmonic motion, and it's modeled by, again, the displacement s of t is equal to 7 cosine of 4t. So the first thing they ask us is for the amplitude. So a is equal to 7, and there's your amplitude. So we got a cosine wave that's basically 7 above the x-axis and 7 below. So it's bouncing between -7 and 7 if you wanted to get a range. So our amplitude is 7. What's the period? Well, b is equal to 4. So our new period is 2 pi over b. All right, actually we should call it omega, huh? Right, so omega, and so we get 2 pi over 4. So pi over 2 is our new period. Okay, so this thing is basically going through I guess a quarter of a rotation. And then what's the frequency? Well, the frequency is basically 1 over the period, right? And so in this case, it's basically omega over 2 pi, right? And so we get 4 over 2 pi, which gives us 2 pi. So there would be our frequency. Okay, and this is the period is measured, basically this would be, I guess we're in seconds, all right, and this would be oscillations per second or cycles per second. Okay, I think we actually call those hertz if I'm not mistaken. Okay, so there you have it. So there's the new thing, the frequency. Finding s of 0, well, that means t is equal to 0. So we have 7, the cosine of 4 times 0, which is 7 times the cosine of 0. Of course, we know the cosine of 0 to be 1. So we're basically starting at 7. So just like a typical cosine graph, right, it starts at a peak. So it starts at 7. All right, and so at 0, we have 7. What's the s of pi over 4? Again, plugging that in, we got 4 times pi over 4. This is 7 cosine of pi. We know that the cosine of pi is -1, so we're at -7. So somewhere down the road, when we are at pi over 4, we're reaching a low point. Okay, so we can kind of start seeing that curve. I guess kind of halfway in between there, pi over 4, I guess that would be pi over 8. I'd expect it to be going through 0 and then doing its action. All right, so we can start getting the curve. All right, and last but not least, let's get technology involved. How do I find the sine of 1.75? Well, what we have here, right, is s of 1.75 would be 7, and that would be the cosine times 4 times 1.75. All right, so I'll reach over to my calculator. I don't have my TI with me right now, but we basically have 7, and then we're doing the cosine of 4 times 1.75. Make sure you're in radian mode, by the way. All right, and let me close the parentheses just to be official. Press equal, and I basically get something like 5.2773. So this is roughly 5.2773. So what does this mean? It means that at 1.75 seconds, where that's at, so let's just say it's somewhere up there, right? We are basically 5.273 units above the equilibrium. So we're actually above it at this juncture, all right? So we're probably, maybe it's even down further down the road, because pi over 4, that's about 0.75. So it's down the road to somewhere in there, but we're off at 1.75. We're 5.2773 above the equilibrium. So that's basically what that means. All right, so again, kind of easy because I gave you the function and we just had to continue to use it. So let's just kind of stay on that vein. Classic example again now is an electrical circuit. When we close an electrical circuit, we've got current moving around in a circle. And so it's basically simple harmonic motion. So what's the amount of displacement that we have? Well, the voltage, right, in the circuit is modeled by, I guess we even call that E of t, is basically 4.5 times the sine of 20 pi t. So again, we know basically what A and omega are. So what's the amplitude? Well, A is 4.5. So there's your amplitude. So we're basically, whatever this graph looks like, right, we're 4.5 above the and negative 4.5 below the equilibrium. What's the period? Well, in this case, omega is 20 pi, right? We used to call it B. So my period is 2 pi over omega. So we get 2 pi over 20 pi, and what we get is 1/10. Okay, so there's, and this would again be measured in, I guess, seconds, right? It's a time unit. So what's the frequency? Well, the frequency is basically the reciprocal of my period, if you would. So we get, we get omega over 2 pi. And so in this case, what we end up with is 20 pi over 2 pi, cancels out, and we're left with 10. And this would be oscillations per second, right, or hertz. All right, so we're going to about 10 cycles per second for this particular circuit. All right, at what time value do we first reach a maximum? So we know the max is at 4.5, and we know the graph is actually starting at 0, right? And under normal circumstances, right, we reach that high point at pi over 2, right? So we know that under normal circumstances, the sine of pi over 2 is equal to 1. So if we multiply that by 4.5, that means the 4.5 times the sine of pi over 2 is equal to 4.5. So there's my high point. So what that basically means is my input, 20 pi t, has to equal pi over 2. Because if I can find the time value where this expression is equal to pi over 2, then I've got all that stuff going. So we basically now solve for t. If we do a quick cross multiplication, we get 40 pi t equals pi. Divide both sides by 40 pi, and it looks like the time value is 1 over 40. So in 1/40th of a second, I expect this a voltage to reach its high point, and it's going to reach that high point several other times, but this would be the first time value when we reach it. And of course, if you plug that in, right, we get 4.5 times the sine of 20 pi times 1 over 40. And so that gives us 4.5. 20 and divided by 4 gives us a half, and we have a pi there. So just like I expected. So we found the time value that makes sine equal to 1, which means we are at the high point of 4.5. So in these cases, I gave you the function, and then we just use that function to answer questions. The classic ones, amplitude, period, and frequency, and then finding some time values, all right, or estimating time values in the future, and just using our knowledge of sines, and maybe cosine graphs is coming up. So that wraps that up. I'm going to do another round where the function's not given. We'll find it and then answer questions based off of our model. See you guys in a moment.